Good evening, class. Today we will be talking about section 5 of chapter 5. It's going to be talking about inequalities in a triangle. This is basically a way for you to be able to look at a triangle and just say if it's been set up properly or if it's even a possible triangle, because certain things need to happen for triangles to be possible. The first thing that we need to know is that this thing called side opposite, it's something we learned back in chapter 4. It's two sides of a triangle that form an angle are called the adjacent sides. Or adjacent to the angle. So if I look at segment AB here and segment AC, they form angle A here at the top. So segment AB and segment AC would be adjacent sides. But side BC here is opposite because it does not form angle A, and it's a side of the triangle. That's what side opposite means. And similarly, if this is the side opposite angle A, well then angle A is this angle opposite side BC. But concept 17 is that the angles and the sides have to match. And what do I mean by that? Is first of all in theorem 5.10, if I have one side being longer than the other side, well then the angle opposite would have to be larger. Correspondingly would be appropriate word, or yeah. So for instance, what if I had segment AB here to be longer than segment AC here? It looks like that. So that means because this segment is longer, that means the angle across, angle C, would have to be larger than, well, I talked about segment AC here, so it would have to be larger than angle B. Or like I said here, if length of segment AB is larger than length of segment AC, then it just follows that the measure of angle C here has to be larger than measure of angle B. Note, there is no equal sign. This is all just work with inequalities. It's also true the opposite way. If I know one angle is larger than the other, like for instance, what if I knew that angle C was larger than angle B? Well, then the side across angle C has to be longer than the side across angle B. That's just straightforward. So that's what this theorem says, 5.11. This does not have a name, but you need to know it. If one side of a triangle is larger than another side, the angle opposite the first side will be larger than the angle opposite the second side. 5.11 says the opposite. If I know one angle is larger than another angle, I know the side opposite the first angle is larger than the side opposite the second angle. So, if AB here is the longest side, angle C has to be the largest angle, period. If angle B is the smallest angle, segment AC has to be the shortest side. It matches up. That's what I mean by angles and sides match. Short goes to smallest. Longest goes to largest. An example here. I want you to draw a sketch of two triangles. I'm going to give you the side lengths and the angle measures. And using this knowledge that angles and sides have to match up, you should be able to draw these shapes. The first one I drew like this. 3, 5, and 7. It honestly didn't matter where I put them. I could have put 3 over here. But what I had to make sure happened was that if 3 here is the smallest number, it's across from the smallest angle, 22. 22 is the smallest angle and 3 is the smallest side. That's why they're across from each other. 7 here is the longest side. 120 is the largest angle. They're across from each other. They're opposite. They match up. This is how you're supposed to draw number 1. Go ahead, try number 2. Again, if you did this correctly, you should have it. It doesn't matter if you put the 6 on the right side and the 9 on the bottom and the 10 on the left side, as long as your angles and your sides match. 6 has to be across from 36. 9 meters has to be across from 63 degrees, and 10 meters has to be across from 81 degrees. These two are roughly these are possible triangles, and this is because they match up across. Alright, what if instead of asking you to draw it, what if I gave you a whole bunch of triangles and said, hey, which ones are clearly impossible? Well, let's just go from this left to right, top to bottom. Upper left here, is 3 across from the smallest angle? Yep. Is 7 across from the largest angle? No. This first one is clearly impossible because the side and angle did not match up. Here in the middle, smallest to smallest, great. Longest to largest, great. Medium to medium, great. They match up. However, this one also ends up being impossible. Oh, I see why. 68 plus 22 is 90, and 90 plus 120 is 210. The angles of a triangle add up to 180. Yeah, I snuck this one in here. This is impossible because the angles cannot add up to be more than 180. The angles have to add up to be 180. So not only do you have to make sure the sides and angles match up across from each other, but you also have to make sure that the angle measures add up to be 180. Alright, now for the upper left. Shortest to smallest, good. Longest to largest, good. This has all of them match up. I add them up quickly. They add up to 180. I think this one might be possible. Bottom left, 4 meters matches up to smallest angle, 22 degrees. 12 meters adds up, or is across from the largest angle, 89 degrees. And if I add them up again, it is again 180 degrees, so I think it's possible. This one here, 1.5 is the smallest, shortest side. 1.5 meters is across from 28 degrees, good. 4 meters is across from 110 degrees, good. Longest matches up with largest, shortest matches up with smallest. This is a possible triangle, I believe. And last but not least, 3 meters matches up to 22 degrees, shortest to smallest. 7 matches up to 120, longest to largest. And 5 matches up to 38, medium to medium. This was the triangle I asked you to sketch before. So, if I did this correctly, I think this one is clearly not possible. They don't match up. Clearly not possible. They don't add up to 180. The angles don't. The measures of the angles don't add up to 180. This one, possible with a question mark. As far as I know, all the rules have been met. This one down here, possible with a question mark. As far as I know, all the rules have been met. Middle one, possible as far as I know, with a question mark. This one here, possible again with a question mark. There might be something I learned shortly that I don't know if it matches up to yet. But that's it. The side and angle across have to match up. Shortest to smallest, longest to largest. This next concept is called the triangle inequality theorem. What it says is the sum of the lengths of any two sides of a triangle is greater than the third side. Well, that sort of makes sense. What if I used a whole bunch of different rulers up here? And I tried to make a triangle. I made one side 2 rulers wrong. Sorry, did I say 2 rulers are wrong? 2 rulers long. So this one here, I measured out a ruler, I measured out another one, and I made 2 of them. And then I made another side that was 1 ruler long. Now, what if for my third side, I chose to make it 4 rulers long? Well, according to the triangle inequality theorem, this won't work because 2 plus 1 isn't greater than 4. And you know what? I think that makes sense. Because even if I would stretch these 2 sides out fully, I don't get this to be all the way across. In fact, I'd be 1 ruler short to connect the last side. All it's saying is that these 2 sides combined has to be larger than this one. Period. The way we say it with an equation form here is this way. Length of segment BC plus the length of segment AB has to be longer than the length of segment AC. But that's not the only way. I have to make sure every single combination works here. That any two sides I add together, their lengths, that it will always be greater than the third length, because it has to make sure that this doesn't happen. This isn't a triangle. There's no way I could ever form a triangle using 2 ruler lengths, 1 ruler length, and 4 ruler lengths. It's impossible. And this is true for any triangle. The sum of 2 of the lengths is always greater than the third. Let's go back to this. Identify the triangles that are clearly impossible. This is example 2 from before. This one we've already said is impossible. This one here we've already said is impossible. These 4 we said possible with a question mark. So let's just check. Does 3 plus 11, is that greater than 7? Well, 3 plus 11 is 14. 14 is a larger number than 7. So yeah, it works there. But I also have to try 11 plus 7. Is that greater than 3? Well, 18, is that greater than 3? Yeah. Now, I didn't have to do these first two, because all I have to do is check if the two smaller numbers is larger than the biggest. So for instance, does 3 plus 7, or 10, is it greater than 11? Well, it isn't. Whoa, so 3 plus 7 isn't greater than 11? This is the only time it could possibly fail, is when I try and add up the two smaller numbers and checking to see if it's larger than the biggest number. So 3 plus 7 is not greater than 11. This one is actually impossible. Back in example 2, we couldn't say if it was impossible before, but now that we know 3 plus 7 here has to be greater than 11, and it's not, therefore it's impossible. Well, now let's look in the bottom left here. 4 and 8 are the two smaller numbers. 12 is the largest, so the only one I have to check is, does 4 plus 8 create a number larger than 12? Well, 4 plus 8 is 12. Is 12 greater than 12? No. 12 is equal to 12. This is actually impossible. If I connected this in a triangle form, I would get a straight line. So far we've eliminated this one, and we have eliminated this one, because the two sides, the two smallest sides added together aren't greater than the largest. Well, what about here? 3 plus 1.5 is 4.5, and that is larger than 4. And 4 is the largest number that I had. So I don't have to check, does 3 plus 4, is it greater than 1.5? I don't have to check, does 4 plus 1.5, is it greater than 3? Nope. All I had to do is check if 3 plus 1.5, is it greater than 4? Yes. This one stays possible. And the last one over here, does 3 plus 5 end up greater than 7? Well, 3 plus 5 is 8, and 8 is a larger number than 7. So yep, this one also remains possible. The two smaller numbers add up to a number greater than the largest side. So it ends up being that using our first rules, we eliminated the first two triangles. But then using our new rules, we eliminated the next two triangles. The only ones that are actually possible is the bottom middle and the bottom right, according to our new rules. Alright, example 4. What if I give you 3 side lengths and say, hey, is it possible to build a triangle using the given side lengths? Well, if I know just the side lengths, all I have to do is check, do the smallest two numbers add up to be a number larger than the third number? So for instance, the largest number here is 9. So does 3 plus 6 create a larger number than 9? No, 3 plus 6 is 9. That's not larger than 9. It is 9. So in this case, number 1 is impossible because 3 plus 6 is 9. It's not larger than 9. Impossible. Now I look at the next one, number 2. 8 is the largest number. So does 2 plus 7 equal a number larger than 8? Well, yeah, 2 plus 7 is 9. And 9 is a bigger number than 8. So number 2 has a possible triangle. This triangle is possible. Well, what about number 3? Hey, Mr. H, 2 of the sides are the same. Okay. Well, which side is the largest still? Oh, this 5 over here? Well, add up the other 2. Check to see if it's larger than 5. So, does 2 plus 2? Well, 2 plus 2 is 4. Is 4 greater than 5? No. So number 3 is impossible. 4. Now, it is still an isosceles triangle. Mr. H, I don't have a largest number. Well, if you don't have a largest number, this triangle has to be possible. Just in plain and simple. If you don't have a largest number, it's a possible triangle. Because no matter how I add these together, it's going to work. 3 plus 6 is larger than 6. 3 plus 6 is larger than 6. 6 plus 6 is larger than 3. Because I don't have a largest number, there's no one that I really have to check. It's going to work. Those 3 sides are a possible triangle. How about 1, 5, and 9? 1 plus 5 are the smaller numbers. That's 6. 6 is smaller than 9. Therefore, 5 is impossible. Those lengths don't add up to be larger than 9. 6. 7 is my largest number. So does 2 plus 5 make a larger number than 7? Nope. Again, it is 7. 7 is not larger than 7. So therefore, 6 is impossible. 2 plus 5 is 7, which is not larger than 7. Therefore, impossible. And the last one, number 7, 5 is my largest number. 3 plus 4 is 7. 7 is greater than 5. So, if I looked at this real quickly, 1, impossible. 2, possible. 3, impossible. 4, possible. 5 and 6, impossible. 7 is possible. And that's how to tell if you can build a triangle using a given side length. Always check to make sure that the longest side is smaller than the sum of the 2 smaller numbers. Alright, example 5. Example 5. Explain why this diagram is impossible. Well, I look at this diagram. I don't have any problem with the right side here. These sides, no issue. I look at this over here. I have no issue with these angles. However, let's just do a little bit of work here. If this is 61 and this is 60, all 3 of these angles here, this one here that's unmarked, this one here, and this one here have to add up to 180. 60 plus 61 is 121. 180 minus 121 is 59. So that means this angle right here is 59. Okay? Well, if this angle here is 59, then its vertical angle here also has to be 59. Wait a second. 59. Either this angle or this angle has to be larger than 59. Just looking over here. In fact, both of the angles over here were larger than 59, but in this case, it doesn't matter how I arrange it. At least one of these are larger than 59, which means 59 is not the largest angle, but it's across from the longest side. This can't happen because this angle doesn't match up to be the largest angle. If it was, I'm fine with it. But unfortunately, this angle has to be, well, not the largest. It could be medium or smallest, but it's definitely not the largest. And it's across from the longest side. This is impossible because they do not match up. That is all I have for you today. You should be able to tell me if angles match up to sides here, largest to longest, smallest to shortest. You should also be able to tell me that the 2 smaller sides here have to add up to be a number larger than the longest side. So 5 plus 12 here is 17, which is larger than 15. Entirely fine. Entirely possible. And that is all I have for you today. Till next time.